The parallel-axis theorem lets us determine the moment of inertia of an object about a new axis parallel to an axis we already know the moment of inertia about. If we let m be the mass of the object and d be the distance from the axis through which we know the moment of inertia, we can say that our parallel axis moment of inertia is equal to our moment of inertia about some central axis plus md squared, where d is that distance that we're offset from that axis. For compound objects that consist of multiple things, we can add together our different moments of inertia and apply the parallel-axis theorem as necessary if we're offset from our central axis. Let's look at an example. If we have our rod, where we know the moment of inertia about the central axis as ml squared over 12, let's say that we want to find the moment of inertia of this about some parallel axis that's offset by L over 2. So rather than the central axis, we want it on the end here. We can start with our central moment of inertia. I naught is ml squared over 12. And then we can apply our parallel axis theorem, adding on md squared, where d is the distance that we're offset parallel to that original axis. Plugging in ml squared over 12, and now our d is equal to L over 2. We have m times the quantity L over 2 squared added to this. We can expand and group, where we end up with ml squared that we can factor out of each term. To get ml squared times the quantity 1/12 plus 1/4. To get common denominator, so we can add those, we get 1/12 plus 3/12, or 4/12, which is equal to 1/3. That leaves us with a final moment of inertia about the new axis at the end of ml squared over 3. Handily, we have this in the table as well. We can look it up in the table and double check. Yes, in the table, I already know that a thin rod about an axis through one end perpendicular to the length is a moment of inertia of ml squared over 3. So that's applying the parallel axis theorem to determine a moment of inertia about some new axis. And this gives us a tool to determine what if instead of at the very end, what if it were halfway to the end at a distance offset by L over 4? We could find that as well.